Hi there, welcome to lesson 1.3, classifying real numbers. We've got two goals today. We want to be able to approximate, compare, and order irrational numbers. And the second goal is to be able to approximate the sum, difference, product, and quotient of irrational numbers. So let's start with our first goal. Here we have a list of 6 irrational numbers. You notice that they're irrational because it's a square root that we don't know the exact answer to. And if I were to type it into the calculator, it's going to be a decimal that goes on forever with no repetition. So here, if you look at I think you can kind of see that. Notice that it's going to go on forever. It goes all the way across the screen. There's no repetition in the digits. So this is irrational. What we want to be able to do is approximate where this is going to be located on the number line below. So what we're going to use in order to be able to do that are the rational square roots that we already know. So this is a really good list for you to kind of be thinking about. So right here with the square root of 17, think about what rational square root is it closest to, or what rational square roots would it come in between? Do you see how it would come in between the square root of 16 and the square root of 25? So we're going to use that to help us out. So a really good list to kind of keep handy. So just to show my work here and to show my thinking, the square root of 16 comes right before the square root of 17, and the square root of 25 comes right after. Well, the square root of 16 is 4, and the square root of 25 is 5, so that would mean the square root of 17 would have to be in between 4 and 5. Closer to the 4 because the square root of 16 is closest to 17. I just deleted this on my calculator. Pulling it back up. Do you see that's about 4.1? Yeah. So we don't want to use a calculator with this. I'm just showing you it with a calculator so that you can see, but no calculator, okay? So we're just going to use what we know in order to help us. So that means when I come down here to my number line, I'm going to place the square root of 17 a little bit after the 4. Just going to make a point right there and call it square root of 17. Okay, so we're plotting it down there. All right, the next one is square root of 5. So think about what rational square roots do you know that's close to 5? Well, you know square root of 4 is 2, and that comes right before. And then the square root of 9 would come right after, and that's 3. Okay, and you can use this to help you if you need to. So here I got square root of 4, square root of 5, and then 9. So this would mean that this would be in between 2 and 3, but closer to the 2. And so if I were to use a calculator, remember we're not going to use one, I'm just showing you here how this works. But it would be right after the 2, 2.2. So just after the 2 here, make a point, and I'm going to name that the square root of 5. Okay, next we have the square root of 91. So think about what perfect square root comes right before it. You got it, square root of 81, and that's 9. So this is going to be a little bit more than 9. If this is 9 times 9, then this is going to be 10, isn't it? 100. So it's going to come right in between there. Okay, so it looks like we're 81 to 91 to 100 is pretty close to the middle there, isn't it? Pretty close. So right in between 9 and 10. So we're going to make a point here and label that square root of 91. Okay, so those were all positives. So you can see that those are all over on the positive side of the number line. Now we have negatives. So we have a couple negatives coming up here. I'm going to slide this over to this side. Whoop, there goes my video camera. Get that back where it needs to be. Okay. All right, so we've got square root of 63. Well, just offhand, I know that the square root of 64 comes right after it. So I'm just going to jot that down there and know that that's 8. So that means this has to be a little bit less than 8, probably about 7.9. I know square root of 49 would come before, but that's way before. So this is going to be really close to 8. So right about here, square root of 63. All right, so positives, got them done. Now let's go to the negatives. Here we have negative square root of 40. So just take that negative sign off of it. Just think square root of 40. What's that going to be in between? Well, you know it's going to be in between square root of 36 and square root of 49. Well, square root of 36, that's right here, 6 times 6. And square root of 49 is right here, 7 times 7. So it's kind of backwards, because the negative square root of 36 would be here. That would be negative 6. And the negative square root of 49 would be right here. That would be negative 7. Because think about, on a number line, you know, the negative 6 and then negative 7 and negative 8. So it's kind of backwards. It makes it a little funky. But it's probably a little, you know, closer to the negative 6, because 40 is a little bit closer to 36. So when I go down here to label it, it's in between the negative 7 and negative 6, but probably a little closer to negative 6. Doesn't have to be perfect. Negative square root of 40. There you are. Okay. Then the last one, 28. Well, just offhand, I can think 25. I know 25, right? 5 times 5 is 25, and then the square root of 36 would be in between. But remember, we have to kind of think of this backwards. So this would be negative square root of 25, because that's negative 5, and negative 6 would be on this side. Looks like that's closer to negative 5, though, because the 28 is closer to the 25. So in between negative 5 and negative 6, but a little bit closer to the negative 5. So right about here, negative square root of 28. There we go. So wow, looks like a lot of work, a lot of writing all over the place. Once you get really good at it, you may not need to write down everything that I just did on both sides, but really having this list memorized, or at least handy, is very, very helpful, okay? So we're using the rational square roots in order to help us estimate or approximate the irrational square roots. Okay, we're going to move on to comparing. So comparing real numbers means rational and irrational numbers. And if you look here, we've got 5.75. That's a rational number. We know exactly what that is, but the square root of 40 is irrational. So we're going to kind of have to estimate to the nearest, maybe decimal, where this would be located. Well, think about your rational square roots. It would probably, square root of 40 would be right in between the square root of 36 and the square root of 49. So if I just show my work here, square root of 36 is 6, and square root of 49 is 7. Think about where this would be. Well, actually, you don't even need to think if it would be closer to 6 or 7. I know it's going to be 6 point something, which automatically makes it bigger than 5.75. So sign would look like that. We go with B. So that wasn't that hard, even though it'd be about, in the middle. All right, let's try this one. So we're comparing 3.1 and the square root of 8. So 3.1 is rational. I know exactly what that is, but the square root of 8 is irrational. Although I do know that it's really close to the square root of 9. So I'm just going to say, okay, the square root of 9 would come right after it, and that is 3. So that this would have to be about 2.9-ish. I mean, it would keep going, but about 2.9. So if this is 2.9 and that's 3.1, this is bigger. So symbol would look just like that. So there's really no work to be shown on the rational numbers. It's the irrational numbers that you have to approximate to the nearest maybe decimal without a calculator, and then compare. Okay, for this next one, I must have forgot to print the page, and I'm at home, so I just wrote it out real quick. Okay, here we have to be able to put a list of real numbers in order from least to greatest. So you see that I have some that are rational, and I have a couple here that are irrational. So we're going to do something very similar to what we did with comparing. If we can approximate each one of these two numbers here, at least to the nearest, decimal, that's going to help us to be able to order the numbers, okay? So I'm going to first take a look at the positive numbers. So I know I have 2. 2 is my positive number, but then also square root of 3. And I know that square root of 4 comes right after, and that's exactly 2. And this is right below, so this would be approximately 1.9. It's, a little bit less than 2. So right now, these two I can put these two in the right order here. 1.9 would come first before the 2. So I know that the square root of 3 would come before 2. Because think about it, 2 is really square root of 4. That comes after. Now I've got these 3 negative numbers. So I'm just going to do a little approximating on this one. I know exactly what this one is. I know exactly what this one is. But I need to figure out about what this is. So I know that negative square root of 36 is exactly negative 6. And this is negative square root of 37. So this is probably going to be a little bit bigger than negative 6. So maybe about approximately negative 6.1. But that's going to help me with these. So I would have negative 4 here. And then between these two, I would first have the negative 6.1, which would be negative square root of 37. And then I would have the negative 6.8. Okay? Because I think that this is backwards, isn't it? So negative 4, and then negative 6.1, and then negative 6.8, getting closer to negative 7 as I move that way. Gets a little tricky with the negatives here. But you just want to be able to get all, especially those irrational numbers, closest to decimals as you can, again, without a calculator, and then putting them in order. Notice how when I put them in order least to greatest, I left them in the exact same form that they were given to me. I didn't change the square root of 3 into a 1.9 when I put it here. I left the numbers the same. All right, our next one before we get to the fun stuff. So here we have a contractor that's tiling a square patio, and the area of the patio is shown right here. And we're asked what is the approximate side length of the patio, and by approximate, they want us to round to the nearest foot. So the area is 136. Now think about if the area of the square was 81. How would you figure out the side lengths of that square? Yeah, right. You'd take the square root of 81, and that would tell you that it's 9 by 9. Same thing if the area was 25, and I wanted the side lengths. How would you find it? Well, of course, you take the square root of 25 to get 5 by 5. So we're going to do essentially the same thing here. To figure out the side lengths of this big square patio, we're going to take the square root of the area. But you notice that the square root of 136, that is an irrational number. It actually fits right in between the square root of 121 and 144. Okay, so it would be about in between 11 and 12. So we want to approximate this to the nearest foot. Is this going to be closer to an 11 by 11 patio or closer to a 12 by 12 patio? So similarly to what we did before, approximating the square root of 136, it would fit in between the square root of 144, which is exactly 12, and the square root of 121, which is exactly 11. So which one is it closest to? So then you have to do a little math and figure out, is 136 closer to 121, or is it closer to 144? Well, it's only 8 away from here, but it's 15 away from here. So we would say that it would be closest to 12. So when it says to approximate the side lengths of the patio, it would be closest to a 12 by 12 patio. So the approximate side length would be 12 feet. So that's how we could we would do a problem like this. Okay, back to our goals. We just got done approximating, comparing, and ordering irrational numbers. And remember, we use this list to help us do that. Then the next goal here is to be able to add, subtract, multiply, and divide irrational numbers. At least approximate what their sums, difference, products, and quotients would be. So notice how we're asked to do this without a calculator, approximating the product. So here are our answer choices. Now these are all just rounded answer choices to the nearest tenth. So we're asked to take the square root of 17 and multiply it by 3. Well, it would be really easy if this was the square root of 16, because that'd be 4, and then the answer would be 12, right? But it's irrational. So we're going to approximate what the square root of 17 would be, and we could just round it really, you guys, to just the nearest whole number, because I think these answers are far enough apart we could do that. So thinking the square root of 17 is really close to the square root of 16. The square root of 16 is equal to 4. So we could say that this is approximately 4. And then if we multiply that by 3, we get approximately 12 as our answer. Now, of course, this is a little bit more than 4, so our answer would be a little bit more than 12. But looking at our answer choices, do you see how far apart they are? We could definitely pick going with A on this one. And again, no calculator. Okay, on the next one, 7 plus the square root of 11. So let's figure out about what the square root of 11 is. We know the square root of 9 is really close to the square root of 11. So we could approximate that this would be a little bit more than 3. So we could say about 3, a little bit more than 3. And if I add 3 and 7, I get 10. So look at the answer choices. Do you see how far apart they are? I mean, this is 10, but we know that that's a little bit more than 3. So a little bit more than 10, it would make sense to be about 10.3. Okay, on number 3. It's a little bit more complicated, doesn't it? But still, it's not hard. So here are our answer choices. We want to find the product here and the product here, and then subtract. So I'm going to put a big dot, because that means multiply these two. A big dot, that means multiply these two. Now let's approximate square root of 34, just off to the side. The square root of 34 is really close to the square root of 36, which is 6. So we're going to say that this is about 6. Just go to the nearest whole number. Then we need to approximate the square root of 2. The square root of 2 is closest to the square root of 1, which is 1. So we're going to say it's about 1. So we have 6 times, and instead of writing square root of 34, I'm going to put 6. And instead of the square root of 2, it's closest to 1. I'm going to put 1. Now, when I multiply here, and then subtract, I get about 24. And if we look at our answer choices, the closest one to 24 would be C. So, I mean, we definitely are not nearly exact, but you have to think, we rounded up on this one, and we rounded a little bit, I guess, down on this one, so we're getting a little higher answer, but it's close enough. Close enough. All right, let's try 4. 4 is kind of interesting because there's a couple different ways you can do this, and it's really cool. I'm going to actually show you later on in the year a different way to do it. But here we have the same square root of 46. So we only really have to approximate square root of 46. And we know that just thinking offhand, that's really close to square root of 49. So I could just say it's really close to 7. Okay, so if I change both of these into 7, so I'm going to change this into a 7 and this into a 7, multiplication. So I have 2 times 7, and here's 3 times about 7. Remember, we're just approximating. So 2 times 7 is 14, 21. When I add those together, I get 35, approximately 35. So looking at the answer choices right here, I would go with B. Now, I want to show you a completely different way of doing this. I think that you'll like it. Think about it as kind of like combining like terms. You have 2 square roots of 46 plus 3 square roots of 46. How many square roots of 46 would you have altogether? Yeah, you'd have 5 square roots of 46. It's kind of like if this was 2x plus 3x, you'd have 5x. So 2 square roots of 46 plus 3 more square roots of 46. You have 5 square roots of 46. So what I can do is just add them together because the radical or the square root's the same, and get this. Now look at how quick this is. 5 times, change the square root of 46 like we did up here into a 7, and we get approximately 35 much quicker. So that's another way to think about it if you want to do it like that. Okay, on this one we have some division. Looks like we're going to have to approximate the square root of 98 and the square root of 26. So just off to the side, we're going to round them just to whole numbers. Square root of 98, yeah, close to this guy right here, right? So we're going to say it's about 10. And square root of 26 is really close to square root of 25, so we're going to say it's about 5. Okay, so remember, this is multiply, this is multiply. Let's rewrite this. So up on the top, I'm really going to have 15 times about 10. Remember, I changed that to a 10. And then in the denominator, I'm going to have 3 times 26 is about 5. And now I'd have 150 divided by 15, which would be approximately 10. So looking at my answer choices, the closest one to 10 would be 9.71, wouldn't it? So just by rounding to the nearest whole number on these irrational numbers, I'm able to get a close enough answer. All right, last one. If you want to pause the video and give it a try, you can. So I want to rewrite both of the irrational numbers. Square root of 8, really close to the square root of 9, which is about 3. And square root of 76, I'm going to have to think it's kind of, which one is it closest to here? Probably have to say 81, huh? So now everything's being multiplied together. I really have 3 times 3 times 2 times 9. So here, this is 9. I'm going to take the 2 9s and multiply them together to get 81. Then I'm going to multiply that by 2, because that way I only have to double the 81. Oh, approximately 162. Approximately. So looking at the answer choices, probably closest to A. Okay, not difficult, right? Okay, back to our goals. So after today's lesson, hopefully you feel like you can approximate, compare, order, and find all of these using irrational numbers. Keep in mind, this is a really good list to have handy or at least memorized, but sometimes it's nice just to take a look at it. I know you have this in your notes from the other day. So thank you so much for joining me. Have a great day.